Hello everyone, myself Maitreya Sarudkar. I am a student at Government College of Engineering, Nagpur. Here, I will present details of the IoT project which I have worked on. I would like to thank Emertxe for offering this amazing internship. I would also like to thank our project guide, Jayalakshmi ma'am. So now, let us begin. First of all, the topics covered in this PPT are Introduction to C Programming, Internet of Things, Embedded System, Microcontrollers, and Project. In project, we will see the overview of project, the objectives of projects, various elements used in the project, and a real-time simulation of the project. So now let us see C programming. So what is the C language? The C language is a high-level general-purpose programming language. It provides straightforward, consistent, powerful interface for programming systems. That's why C language is widely used for developing system software, application software, and embedded system. Now let us see the structure of a C program. As you can see, there is a header file. So what is header? It is a file that contains set of predefined standard library functions. Main Main is a primary function that serves starting point for program execution. Return. A return statement ends execution of a function and returns the control to the function from where it was called. Now let us see topics covered in C. Our first topic is data type. Data types are types of data stored in C program. Types of data types are character, integer, float, and double. Our next topic is conditional and loops. Conditionals are programming constructs that allow a program to execute different blocks of code based on whether a certain condition is true or false. Examples of conditionals are if, else if, and else statements. Loop. Loops are used to execute block of code repeatedly according to the condition given in loop. Example of loops are for loop, while loop, and do while loop. Operators. An operator is a symbol that tells the compiler to perform a specific mathematical or logical function. Types of operators are arithmetic operator, relational operator, and logical operators. Arrays. Array is a collection of similar data types. Pointers. A pointer is a variable that stores the memory address of another variable as its value. String. A string in C programming is a sequence of characters. Strings are used to store text and characters. Function. A function is a group of statements that perform a specific task together. Storage class. A storage class in C programming are used to determine the visibility, lifetime, and memory location of any given variable. Preprocessor. The C preprocessor is a microprocessor that is used by compiler to transform our code before compilation. Now, let us begin with Introduction to IoT. IoT stands for Internet of Things. It describes physical objects or group of such objects with sensors, processing ability, software, and other technologies that connect and exchange data with the other devices and systems over the internet or other communication networks. IoT is a network of interconnected computing devices which are embedded in everyday objects, enabling them to send and receive data. Now, let us see applications of IoT. Applications of IoT are not restricted to a certain domain. They include various fields such as home automation, smart cities, environment, energy systems, logistics, industry, agriculture, and health. As you can see, I have listed examples of applications of IoT through this diagram. Now, let us see what is embedded systems. Embedded system is an integrated system that is formed as a combination of computer hardware and software for a specific function. It can be said as a dedicated computer system has been developed for some particular reason. But it is not our traditional computer system or general purpose computers. These are embedded systems that may work independently or attached to a larger system to work on a few specific functions. These embedded systems can work without human intervention or with little human intervention. Some examples of embedded systems are digital watches, washing machine, toys, televisions, digital phones, laser printer, cameras, etc. Now let us see application fields of embedded system. Application of embedded systems include various fields such as home appliances, transportation, healthcare, business sector and offices, defense sector, aerospace, and agricultural sector. Once again, I have listed examples of applications of embedded systems through this diagram. Now, let us see what is microcontroller. A microcontroller is a small and low-cost microcomputer which is designed to perform the specific task of embedded system like displaying microwaves information, receiving remote signals, etc. The general microcontroller consists of the processor, the memory, RAM, ROM, EPROM, serial ports, peripherals, timers, counters, etc. The image shows Atmega 328P microcontroller. Now let us discuss about the project. First of all, we discuss the overview of the project. This project provides IoT-based home automation solutions using Arduino Uno board in PiximLab simulator. To remotely control the device, we use an app named Blink IoT. We automated the garden lights where they brighten according to sunlight. Temperature control system is automated. The water tank is automated by controlling the inlet and outlet valve respectively. The objective of these projects are connect all the discussed home appliances to Arduino PiximLab and integrate it with Blink IoT app and cloud. Obtain critical notifications regarding temperature and water tank on the Blink IoT app. To check real-time status of temperature and water level on Blink IoT app. To control garden lights automatically. Now let us see what is home automation. Home automation is the automation of common household activities and processes having a centralized control. Home automation involves a network of interconnected smart devices communicating via Bluetooth and Internet. Each device uses mechanisms and sensors to automate tasks around your house, allowing you to control them via your smartphone. Now let us see various elements used in this project. Our first element is Arduino Uno. The Arduino Uno is an open source microcontroller board based on microcontroller Atmega 328P. The board is equipped with sets of digital and analog pins that may be interfaced to various input-output expansion boards and other circuits. It has 14 digital input-output pins, in which 6 can be used as PWM outputs, 6 analog input-output pins, a 16 MHz ceramic resonator, a USB connection, a power jack, an ICSP header, and a reset button. Arduino Uno can be programmed using various IDEs. We used Arduino IDE for this project. The image here shows Arduino IDE. Our next elements are PiximLab and Blink IoT application. PiximLab. PiximLab is an open source real-time emulator of development boards with integrated MP-LabX AVR GDB debugger. It has integration with Arduino IDE for programming the board's microcontroller. Blink IoT application. Blink is an IoT platform for iOS or Android smartphone that is used to control Arduino via internet. Blink app allows you to create interface for projects using various widgets provided. Blink server responsible for all communication between the smartphone and hardware. Blink libraries enable communication with the server and process all the incoming and outgoing commands. Our next element is LDR. An LDR or light dependent resistor is also known as a photoresistor, photocell or photoconductor. It is a device that is used to detect light. It has a variable resistance that changes with the light intensity that falls upon it. This allows them to be used in light sensing circuits. The LED lights are connected to the LDR via ADC. The ADC converts the analog input by the LDR into its equivalent digital form, which is converted later by a certain formula from 0 to 255 as upper bound. Based on that, we glow the LED. Now, let us see garden lights control. The properties of LDR sensors are applied to accomplish the controlling of garden lights. During the day, the outdoor light is maximum, so the LDR sensor detects the light and the garden light is turned off. Whereas at the night time, the outdoor light is very low, so the LDR sensor detects the light and the light is turned on. The image below shows diagrammatic representation of function of garden lights control. The LDR sensor is directed towards Arduino Uno and Arduino Uno is directed towards the light. Our next element is temperature sensor. The LM35 is a sensor that measures temperature. The prefix LM stands for linear monolithic. The temperature is recorded using LM35 sensor which reads analog values. The values is converted into binary value and the later actual temperature is calculated using the obtained value of voltage. This sensor doesn't require any external calibration to provide accuracies in result. Now let us see temperature control system. The temperature control system consists of heating resistor, an LM35 temperature sensor and a cooler. Analog value of temperature is obtained from the temperature sensor LM35 and display it on CLCD after converting it into digital value using ADC. Control the temperature of the system by turning on or off the heater and cooler through the Blink IoT application. The feature of this system is that as the temperature reaches 35 degrees Celsius, the heater turns off automatically to avoid more heating. The notification of the same is displayed in the terminal Blink IoT. The image here shows diagrammatic representation of how temperature control system works. Now let us see water inlet and outlet valve control. Read the volume of the water in the tank through serial communication and display it on the CLCD. Control the volume of water in the tank by controlling the inlet and outlet valve by sending commands through serial communication. Display the volume of water in the tank on the CLCD and also on the Blink IoT application. Here, the main feature is that as soon as the tank is full, the inlet valve is turned off, and when the water level in the tank is below 2000 liters, the inlet valve is turned on automatically and the notification for the same is provided on the terminal of Blink app. Given here is the simulation of our project. On the left hand side, you can see spare parts of PiximLab. We will see all these components very shortly. On the right hand side, on the top, you can see serial tag, and in the bottom, it is PiximLab simulator. Now we move towards the conclusion of this project. Using Blink IoT application and PiximLab simulator, we simulated home automation, where LED, temperature system, serial tank resembles light, heater, cooler, and water tank in real time. CLCD acts like a dashboard used for displaying the events widgets from Blink IoT app, like button widgets are used to control heater, cooler, and inlet valve, outlet valve. Gauge widgets used to display the temperature and volume of the water. Now we will see the code and real-time simulation of our project. So now let us have a quick overview of the code. This here is the Blink authentication token which is unique for every device. Here are some standard preprocessor directives which we will need to run our code. Coming down here, this is our Blink write cooler virtual pin. This works to turn on and off cooler based on the virtual pin value. This here is the heater virtual pin. This also works to turn on and off heater based on virtual pin value. This here is the inlet virtual pin. It is used to turn on and off inlet valve based on virtual pin value. This is the outlet virtual pin. It is also used to turn on and off outlet valve based on the virtual switch value. This here is the update temperature reading function. We will update the temperature as well as volume so that they can be displayed on the gauge on Blink IoT app using this function. This here is the handle temperature function. Here, as you can see, if the temperature rises above 35 degrees Celsius, the heater control turns off and we get the notification that temperature is above 35 degrees Celsius. As you can see, we are initializing the value again to 0. This is the handle tank function. As you can see, if the volume of the water is less than 2000, we will enable the inlet valve, we will put the value of inlet switch equals to 1 so that the tank starts filling again. So if the volume reaches 3000, which is the full capacity of the tank, we will disable the inlet valve and we will initialize the inlet switch value to 0. As you can see, we are getting the notification that tank is full and turning off the inlet valve. This here is a setup code. Here we have initialized the temperature system, the serial tank, and the timer. This here is the loop. Inside loop, we keep the code which we want to run repeatedly. Let us go to the ldr.cpp. Here we have garden light control and we have initialized the LDR function. Going to ldr.hv. Here we have defined macros for LDR sensor and garden light. This is the main file, and here we have initialized macros for temperature gauge, cooler virtual pin, heater virtual pin, water volume gauge, inlet virtual pin, outlet virtual pin, and blink terminal virtual pin. Going to the serial tank code. This here is the serial tank code. Here we have defined functions such as enable inlet, disable inlet, enable outlet, and disable outlet. Here we have defined macros for inlet valve, outlet valve, high float, low float, volume, and enable, disable. Going to temperature system code. Here we have provided initialize temperature system function. This here is the read temperature function. This function is used for cooler control and this function is used for heater control. Here we have defined macros for heater and cooler. Now we will see the real-time simulation of our project. This is PiximLab. This is Arduino Uno board. This is Atmega 328P microcontroller. This here is the Ethernet shield. Now we move towards the spare parts. This here is the CLCD which is used to display notifications. These are the LEDs, that is garden lights. This is the LDR setup and you can see LDR sensor here. So depending upon the variable resistance, you can see the brightness is increasing or decreasing. This here is the temperature control system. It has a built-in LM35 sensor. This is a cooler. This is Ethernet and it is used to connect Arduino Uno board with these components. Now I will share my phone screen with the help of a power mirror. As you can see, I have mirrored my phone. This is the Blink IoT app and you can see tab 1 and tab 2. The tab 2 belongs to the serial tank. In serial tank, we can see it is connected through serial port COM2. The inlet valve is off and the outlet valve is also off. The total capacity of this tank is 3000 liters. Now on the CLCD, we can see the temperature 27.34 degrees Celsius, which is the normal room temperature. Now if I turn the heater on, as you can see, the temperature is increasing. As soon as the temperature goes above 35 degrees Celsius, we get the notification that temperature is above 35 degrees Celsius, turning off the heater. Now if I turn on the cooler, as you can see, the temperature has started decreasing. It maintains the room temperature of 27.34 degrees Celsius. Moving towards the serial tank. Now if I start the outlet valve, you can see outflow on, we get the notification. As soon as the volume goes down below 2000 liters, you can see the inlet valve start automatically. Now if I close the outlet valve, we receive the notification that outflow is off. Now as soon as the volume reaches 3000 liters, you can see the inlet valve turns off automatically and we receive the notification of same that volume of water is less than 2000, turning on the inlet valve, tank is full and turning off the inlet valve. That's all in the simulation. Thank you.